Hi, welcome in. Today we're going to talk about parallel lines and proportional parts. And you'll see that when we have proportional parts of triangles, we can divide segments into different parts for the triangle. So we have a couple different theorems. Uh, this is a lot more fun on the smartboard where you can actually fling it and throw it, but we'll work without it. Triangle proportionality theorem is if a line is parallel to one side of a triangle, then it separates these sides into proportional lengths. So in previous lessons, we compared whole triangle side to whole triangle side. If we have parallel lines, we can say part to part is proportional to part to part. Just be careful that you always know what you're comparing. So you compare part to part, you can compare side to side, side to side, but you can't compare a part to a side, a part to a side. So just make sure you always are consistent with what you are comparing. The converse is also true. So we'll be asked in some problems, are these lines parallel? What we'll do is we'll check to see if the parts are proportional. If the parts are proportional, then yes, we'll say that they're parallel. If they're not proportional, then they're not parallel. Then lastly, we'll move this. So if three or more parallel lines intersect two transversals, then what happens is they cut those transversals proportionally. So notice we have three sets of parallel lines, not necessarily dealing with a triangle anymore, three sets of parallel lines. Then the parts that it intersects, those parts are proportional. So the two parts of line T, A and B, is proportional to the two parts of line S, C, and D. Those are three theorems that we'll use. So let's do some problems and some examples of that. So again, you can do side to side with the whole triangle or part to part. For this particular one, I will do part to part just to show you that it works. So we have part to part 18 to 6, which I'm going to simplify to 3 to 1. Goes part to part. Make sure you stay consistent. I did this part over this part, so stay consistent. That part over that part is x plus 22 over x plus 2. When we cross multiply, don't forget to distribute. So you have 3x plus 6 is equal to x plus 22. Subtract the x is 2x, subtract the 6 is 16, divide by 2, and x is 8. Okay, comparing part to part, part to part. So be careful, this is a part 11, but this is the whole thing. So you either need to compare whole side of the small triangle to whole side of the big triangle, or part to part. Either way, you either need to add these together to get the whole side or subtract these to get this part. I'll subtract these. 33 minus 11, this part is 22. So when I go part to part, 11 over 22, you can choose to simplify or not simplify. I like to simplify for the most part. Sometimes I don't. That simplifies to 1/2. I did the smaller part over the bigger part, smaller part over the bigger part, x over x plus 12. Cross multiply, you have 2x is equal to x plus 12. Subtract the x, and x is equal to that 12. Here we have three sets of parallel lines, so we can say that their parts are proportional. So when we have three parallel lines, again, all of their parts are proportional. Notice here, I'll just call this y, which means this is y, which means this is y. So you have y over y, which is 1. So again, if these parts are congruent, then these parts are congruent. So pick any two of the three parts, and you know that they are equal because it's proportional, so these parts need to be equal too. I'll just choose the x plus 3 and 12. Those seem like the simplest two. Subtract the 3, and x is 9. So again, for these two lines, when we have three sets of parallel lines, which we do, 1, 2, 3 parallel lines, for each transversal, part to part, 3 over x is proportional to the other parts, so 4 over x plus 4. So we have 4x, make sure we distribute, is 3x plus 12. Subtract the 3x, and x is equal to 12. Again, part to part, so you have 5 over 8 is equal to y over y plus 2. Cross multiply, I have 8y is equal to 5y plus 10. Subtract the 5y is 3y. Divide by 3, and y is 10/3, or 3.3 repeating. Notice here we have our three parallel lines, but these parts are equal. So these parts are equal, so I can say 3x minus 1 is equal to 2x plus 4. Subtract the 2x is 1x, add 1 is 5. Once again, you know if things are proportional and these parts are equal, that means these parts need to be equal as well. So 3y is equal to 2y plus 2. Subtract the 2y, and y is equal to 2. Triangle midsegment theorem. Our first one is that the midsegment of a triangle is parallel to one side and half of its length. So if xy is a midsegment, then xy is parallel to rs, and xy is equal to 1/2 of rs. So it's almost similar to a median of a trapezoid. So again, if it's a midsegment, it means we're connecting midpoint to midpoint. So this is the midpoint, this is the midpoint. Again, so it's saying part to part, part to part. Just like when we talked about these ones, if we have parts and parts, then they're proportional, which is why we're doing it in this lesson. We can also say that this length, xy, is 1/2 of the whole thing. The reason why is because if I call this x and x, this side here is x compared to the whole side, x to x is 2x. And so when we have those parallel lines, we have proportional sides, and this ratio is 1/2 to the whole thing. So again, parallel lines, we know it's a midsegment because it connects midpoint to midpoint. X is 1/2 of 35, so x is 17.5. Triangle has vertices A, B, C. It says the midsegment DE is parallel to BC. Find the length of DE. Well, we know that the length of the midsegment is 1/2 the length of the line that it's parallel to. So let's find the line that it's parallel to. So BC, the distance between x and y, the difference, -3 and 7 is 10. Between -2 and -2 is 0. So I have the square root of 100, which is 10. We know that the midsegment is 1/2 of that parallel line side, so 1/2 of 10, and DE is 5.